studying losses due to friction in pipes. So, when a fluid flows through a pipe, this is section 1 and this is section 2, and if it is moving from 1 to 2, there is always pressure loss. This loss occurs due to friction, and the pressure loss is known as head loss. So, that head loss takes place due to viscosity, movement of molecules against each other and across the wall. It depends upon surface roughness of the wall. This is major loss when it flows through a uniform pipe. There are enlargements and contractions, there are bends, there are walls. So, when the flow takes place across these, that is enlargements, contractions across the walls, they are known as minor losses. So, again we know that there are two types of the flow, important types, laminar flow and turbulent flow. The equations are available for calculating friction factor. So, this is for turbulent flow, this is known as Darcy-Weisbach equation, and for laminar flow generally Hagen-Poiseuille equation is used. So, in the equation, in the experiment we are using two test pipes, half-inch diameter and 3/4 inch diameter. The data is, as you know, acceleration due to gravity is 9.81 meters per second square. Same procedure used for flow calculation, that is area of measuring tank 0.0677 meters square. These are the pipe diameters and these are the distance between pipes, because we are measuring pressure loss, we are measuring pressures at two pressure tappings. So, distance between two tappings is L. So, this is important, because in the friction factor equation we use various terms like this length L, and across this length L the pressure loss, that is pressure head loss. So, for this the different equations used are head loss is H1 minus H2 upon 100. So, we use manometers for measurement of this. Again this R is level difference in the measuring tank, then flow rate Q is area of tank into level rise and divided by time for that level rise. So, velocity is flow rate in meter cube per second divided by cross sectional area. So, this is velocity is Q by A, Q is calculated here and A is area of cross section, that is for this area, this diameter for a 3/4 inch pipe and this diameter for half-inch pipe, that is half-inch and 3/4 inch pipes are used. So, these diameters are taken for calculating this area A. Then according to Darcy-Weisbach equation, we can write this friction factor as head loss multiplied by G multiplied by diameter of pipe multiplied by 2, whole thing divided by 4 into L, that is the length across which we are measuring pressure loss, that is length between pressure tappings, and velocity square. So, note that this friction loss friction factor is HFGD into 2 divided by 4 L V square, or if we consider HF head loss, then V square term comes to the numerator. So, this HF head loss depends upon velocity and it is proportional to square of the velocity. The observations taken are these H1, H2 readings. As the flow changes, the pressure drop changes. For one particular flow, we are measuring this head loss or pressure loss, and the flow rate is calculated using this standard method, keeping R2 fixed and measuring R1 using some fixed time constant. This is the experimental setup, exactly same as the earlier experiments. This is circulation pump, this is bypass valve, so we can control water going through this main circuit. This is measuring tank and glass tube and scale for measuring level difference for calculation of flow rate. This is sump tank. These are the piezometers connected to two pressure tappings, H1, H2, that is upstream side and downstream side of the flow. There are two pipes, half-inch pipe and 3/4 inch pipe. So we can allow flow to pass through half-inch pipe or 3/4 inch pipe using this cock. We can start and stop flow in one pipe or the other. So these are the piezometers for pressure drop measurement, and this is the distance L, this point to this point, this point to this point. So this is length L across which we are measuring this pressure drop, that is pressure head loss across a specified length L. So this is used for removing air from these manometers. So this is used for removing air removal purpose. So again, this is the connection for passing flow into measuring tank or main sump, as usual with the procedure used in earlier experiments. So we have started the circulation. You can see the level difference. This is H1 and this is H2, and the flow is passed through 3/4 inch pipe, and we will measure time for this flow. So the initial reading is 8 centimeters. This initial reading is 8 centimeters, and I am allowing to pass it through for 10 minutes. So this is the time recorded and the level recorded. Then this is H1 is 71 centimeters, and we can read this H2 also. This is set of observations. Now particularly in this experiment we are not keeping this R2 constant, because it's convenient to keep this R2 constant, but it is not necessary also. So the first set, H1 is 71, H2 is 61, R1 is 12, R2 is 8, and the time for changing this R from 8 to 12 is 10 seconds. So this is second set, 77.2 centimeters H1, H2 67.7 centimeters, R1 15.9 centimeters, R2 12 centimeters, and time is 10 seconds. Likewise, this is third set and this is fourth set. So you can see the difference between H1 and H2 values. This H1 minus H2 is always positive, that is delta H is negative. So this indicates pressure head loss or pressure loss when water or fluid flows through the pipe, and the distance between H1 and H2 is this L. Similarly, the experiment is repeated for half-inch pipe also, and these are the sets 1, 2, 3, 4. The first set of readings is H1 83 centimeters, H2 63 centimeters, R1 12.1 centimeters, R2 8 centimeters, and time 10 seconds. Likewise, this is second set, third set, and fourth set. So again I will repeat this calculation part. So this HF is modulus of H1 minus H2 by 100, R is R1 minus R2 by 100. This is just in case if we misplace H1 and H2, instead of write H1 and H2, if we write H2 and H1, then the modulus sign takes care. This value is always positive. This value is always positive. Q is A into R by T, velocity is Q by A, and friction factor is calculated for the circular pipe. F is equal to HF into G into D into 2 divided by 4 into L into V square. So calculate F for all these readings for half-inch pipe as well as for 3/4 inch pipe for the all sets of observations. This gives value of friction factor. Thank you.